to the massive earthquake that woke up Alaska.
Now breaking news, a powerful earthquake has struck southern Alaska, triggering a tsunami warning.
The growing unrest beneath Alaska's Aleutian subduction zone has pushed scientists, emergency planners, and coastal communities into a state of heightened vigilance. Recent seismic activity in the region, particularly the cluster of 8 magnitude 5 or higher earthquakes in the Andreanof Islands within just 48 hours, is prompting urgent questions about the future. The fact that these quakes occurred in close proximity, both spatially and temporally, suggests that stress may be transferring along connected fault segments. This pattern, which resembles the precursor activity observed before the devastating 2011 Tohoku earthquake in Japan, points to a heightened probability of a much larger seismic rupture. If such an event were to occur in the Aleutians, the consequences could be catastrophic not only for Alaska, but for vast areas across the Pacific. In January 2025, researchers convened at the U.S. Geological Survey's Subduction Zone Science Conference to examine this mounting evidence. Field data, seismic records, and tsunami modeling were scrutinized in an effort to interpret whether the Aleutian arc is merely rumbling or signaling an imminent disaster. Much of the concern revolves around the region's unique geological setting. The subduction zone is characterized by slow, nearly imperceptible motion as tectonic plates grind and strain over decades. This silent accumulation of stress ultimately leads to sudden, violent releases, often without the typical warning signs. Unlike mainland cities with extensive infrastructure and established evacuation systems, many of the Aleutian communities, such as Adak and Atka, are small, remote, and lack sufficient routes to safety. Their deep-rooted indigenous populations and vital military installations face disproportionate vulnerability. An earthquake of sufficient magnitude could not only destroy these towns, but also compromise communication lines, destroy docks, and provoke undersea landslides capable of generating enormous tsunamis. The possibility of a mega-tsunami, potentially hundreds of feet tall, is not just theoretical. Geological investigations have found submarine landslide scars around major volcanoes such as Mount Cleveland and Mount Shishaldin, evidence of massive terrain collapses that displaced colossal volumes of water. These scars are relatively recent, geologically speaking, ranging from a few hundred to several thousand years old, indicating that these events are not distant relics but recurring geological phenomena. In 2017, a landslide in Ta'an Fjord, Alaska, generated a wave nearly 600 feet high. Though this occurred in a sparsely populated area, the event serves as a stark example of the potential consequences should a similar slide happen closer to shipping lanes or during a peak fishing season. With several of the Aleutian volcanoes built from loose ash and volcanic rock, their flanks are structurally weak and susceptible to collapse, especially when shaken by seismic activity. These volcanoes, many of which rise directly from the ocean floor, tower steeply with little support. A major eruption or quake-triggered landslide here could unleash a surge of energy across the Pacific, sending tsunamis racing at jetliner speeds toward distant shores. What intensifies these fears is the multi-hazard nature of the Aleutian environment. Volcanic activity, seismic movement, and underwater landslides are not isolated threats but interconnected components of a volatile system. In confined basins or shallower waters, even a modest eruption could destabilize the seabed or collapse a volcanic flank, generating tsunamis of devastating scale. Unlike more visible land-based volcanoes, submarine volcanoes are difficult to monitor. Advances in sonar mapping and satellite altimetry have only recently begun to illuminate their histories and structural vulnerabilities. Early signs of volcanic unrest in 2025, such as gas emissions, increased vent temperatures, and newly formed fissures, raise the stakes even further. These underwater giants, some named and many unnamed, stretch across the ocean floor in a largely hidden realm. Though unmonitored for decades, recent efforts using robotic submersibles and seismic arrays are beginning to paint a more detailed picture. The data is troubling. Low-frequency tremors, often the first indication of magma movement, have been recorded at increasing rates. Rising temperatures and gas emissions from hydrothermal vents are further evidence that magma is on the move. These signals do not always precede eruptions, eruptions, but their presence suggests increasing volatility. One of the primary fears among geologists is that such volcanic activity could act as a trigger for cascading failures. A sudden eruption could destabilize a slope, displace sediment, or even rupture the sea floor. Such events might, in turn, provoke further seismic activity. In an environment where so many elements are tightly coupled, the risk is not merely one large event, but a domino effect of disasters. The worst-case scenarios modeled at the recent scientific summit involve combinations of seismic and volcanic triggers leading to multi-stage disasters. An earthquake, followed by a landslide and tsunami, or a volcanic collapse that sets off further seismic ruptures. One major hurdle in forecasting these threats lies in the subtlety and complexity of the signals. Despite technological advances, distinguishing between benign background noise and early signs of catastrophe remains a formidable challenge. New sensor networks, GPS arrays, tilt meters, ocean bottom seismometers track minute changes in elevation, slope, and movement. Yet these tools, while promising, still provide limited lead time. Many significant geological events offer only moments or at best a few hours of warning. The Andrianoff Island quake cluster fits some known patterns but lacks the consistency required to definitively predict an impending megaquake. What adds to the complexity is the possibility of stress transfer between tectonic regions. The Aleutian and Cascadia subduction zones are part of a broader Pacific plate system. Though separated by geography, they are interlocked through vast tectonic forces. A major event in one zone can redistribute stress across the plate boundary, potentially triggering activity in the other. Historical and simulated data both suggest this is more than just a theoretical possibility. Multi-zone ruptures, while rare, have occurred in other parts of the world and serve as cautionary examples. Should a powerful quake strike the Aleutians, scientists fear it could destabilize the Cascadia Fault, with compounding impacts along the Pacific Northwest. Alongside all the new research and technological improvements lies a growing concern about public readiness. Despite clear geological risks, public perception often underestimates the threat. Many communities across the Pacific Rim, California, Oregon, Hawaii, Japan, New Zealand, remain at risk from Aleutian-driven tsunamis. Yet the time window for effective response is slim. In some cases, coastal areas could be struck within a few hours of a rupture. Emergency preparedness varies widely, and even in developed regions, evacuation plans and public awareness campaigns may fall short under real-world pressure. The quiet periods between disasters often lull populations into a false sense of security. The geological record, however, tells a different story. Layers of sand and marine debris embedded far inland in places like the Bering Sea and the Pacific Northwest are remnants of ancient tsunamis, some so large they reshaped coastlines and ecosystems. These prehistoric records, uncovered through soil core sampling and sediment analysis, offer chilling evidence of the scale of past events. In some cases, the water moves so far inland that forests were uprooted and entire landscapes submerged. The fact that some of these deposits date back only a few thousand years suggests that such events occur more frequently than once assumed, and yet much of the older evidence has been erased or obscured by modern development and environmental change. As a result, scientists may be underestimating the true recurrence interval of major tsunamis in the Aleutian region. This adds another layer of uncertainty to already complex hazard models. With every new deposit or seismic anomaly, researchers update their risk assessments, but the vastness of the Pacific and the limits of human observation make it difficult to grasp the full picture. Within this context, the question arises, is the Earth entering a period of intensified seismic activity? Some scientists posit the existence of supercycles, periods when several of the world's major fault zones approach critical stress thresholds around the same time. Though the concept remains speculative, the clustering of high-magnitude events across different parts of the globe suggests that global stress patterns may sometimes align. If the Aleutians, Cascadia, and other zones were to rupture within months or years of one another, the consequences for human civilization would be profound, not only in terms of lives lost, but also economically, socially, and geopolitically. Shipping lanes, energy infrastructure, and global supply chains all traverse the Pacific. A significant disruption from a tsunami or quake could paralyze these systems. Ports might be damaged, trade routes closed, and energy supplies disrupted. Recovery could take months or years. Insurance costs would skyrocket, and the economic shock could be felt far from the epicenter. The interconnectedness of the modern world means that no region is truly isolated from such a disaster. Even countries not directly struck by a tsunami could suffer consequences through disrupted commerce, displaced populations, and global economic ripple effects. The 2025 summit served as both a scientific forum and a public warning. There was sobering discussion about the limits of current tsunami warning systems and the persistent challenges in getting people to act quickly during emergencies. Past tsunamis, including those in Indonesia and Japan, revealed how delays, poor communication, and disbelief can lead to avoidable fatalities. The science is advancing, but without public trust and efficient infrastructure, its benefits may be muted. Meanwhile, research continues to probe deeper into the seabed. Robotic drones explore underwater volcanoes and landslide scars. Satellite sensors scan the ocean surface for anomalous waves and subtle shifts. Every new tremor, every abnormal temperature reading is analyzed for patterns. Still, Earth's internal processes remain unpredictable. Despite decades of study, we still do not fully understand the interplay between magma, water, and tectonic pressure beneath the sea floor. Yet the urgency remains clear. The Aleutians are not dormant. They are a seething, grinding frontier between Earth's vast plates, accumulating energy with each passing year. The next great upheaval may be decades away, or mere weeks. The clues are there in the geological strata, in the seismic chatter, in the bubbling hydrothermal vents. Whether humanity can decipher them in time is still an open question. The 2025 earthquake swarm, the volcanic unrest, and the expanding field of submarine landslide research all point to one conclusion. The Aleutian subduction zone remains one of the most dangerous and least predictable regions on the planet. The stakes are enormous, and the margin for error is slim. Scientists armed with new tools and knowledge are doing all they can to improve predictions and bolster preparedness. But the forces at play are immense, and in many cases indifferent to human understanding. While hope lies in technology, caution demands humility. Nature has often proven more complex than our models, more violent than our warnings, and more sudden than our systems can handle. Each advancement in research brings us closer to understanding, yet also reminds us of how much remains unknown. The Aleutians may hold steady a little longer, or they may be on the brink of rewriting Pacific history. Whatever happens, the world must be ready to listen, respond, and adapt, because the ground and sea beneath us are never truly still.